Hey guys, welcome back to another episode of Simuleos. Here's the thing. There might be a little bit of latency between the camera and the audio. That's because I record the camera and audio from two different channels. And for some reason, OBS doesn't really sync them up very well, so I have to manually sync them. And today, for some reason, the sync was a little bit different than how it normally was. So if there's some issues there, let me know. I can try to fix it in the next few minutes. If there isn't so much of a difference, that's probably okay. It's better than it was like a month ago or whatever, when for some reason there was like a full second delay or something like that. It shouldn't be too noticeable, but I just wanted to bring it up in the case that someone did notice it and did want to talk about it. Let me check real quick just to... Yep, okay, good. So I am up, should be okay. Again, for today we have a whole bunch of stuff we need to get done. So we're going to be mainly going back through Huffman Encoding. Now, while I was sleeping last night, right at the end of stream, there was a Rust version of the Huffman encoding algorithm put up by Gustorn on the Discord chat. That was very, very useful, but I don't really know Rust. But that will probably be put into the algorithm archive when we get to it. And then the other thing was he put up a Huffman version for the Julia language. Now, the thing is, we're writing in Julia right now. I haven't quite been able to go through and figure out exactly what's going on with all the tricks there with the Julia code. So for now, we'll still be using my Julia code, but there are a whole bunch of good things there with the Huffman.jl that he posted. So I figured I would go ahead and put that here in the chat in the case that anyone wanted to take a look at it. Again, he does something kind of similar to what I did, where I generated a kind of abstract class or an abstract type. He created a union of two types, which would be a leaf and a branch. And I think that's also a fair way to do it. Now, one thing to note is he didn't have to keep the bit strings with his values here because of the way that he generated his codebook. And he has this codebook recurse function down here. I just couldn't quite figure out how it worked, if I'm being honest. So that was kind of why I haven't quite used it yet, or I haven't quite, how do I put this? Man, I cannot speak today. Today's one of those days that I just can't seem to make a clear sentence. But basically, yeah, he has this this function in here. So we might take a look at it in just a second as we're going through and trying to optimize our Julia code and go from there. As a side note, one of my friends on Twitter, his name is 12Tone. He's also one of my friends, I guess, on YouTube, and he's part of this other community that I'm a part of for like YouTube creators and stuff like that. Anyway, he went through and he asked the other day if there would be people willing to basically watch a stream where he played piano the whole time, right? But the thing is, he's a music theorist. So I guess the idea would be that he plays piano and he describes like why he's improvising in the way that he's improvising, that type of thing. So I would be very interested in this stream kind of just because it's something non-gaming related on Twitch. I'm kind of a fan of non-gaming related stuff on Twitch. But I was wondering what your guys' opinion was. Do you think it'd be a good idea for him to start the channel, or do you think it'd be better for him to, I don't know, maybe stick with YouTube and not move on to Twitch? Hey JSPP, thanks for coming in. Also, thanks to anyone else who might be in the chat but just lurking. Thanks for coming in, I really appreciate it. Okay. So as far as things that we're going to get done today, the first thing we're going to do is look back at our Huffman code because there were a few things that we wanted to take a look at, just see if it's easier or not to do it a certain way. Now, in the end, with Huffman's Julia, or dag nabbit, with Gustorn's Huffman code in Julia, again, he's got something very similar where he has two structs, one leaf and one branch, and I did something like that for my system. So we'll take a look at the nullable stuff, just because I'm interested in figuring out how it works in Julia, but I don't think we'll spend too long on that. I think the bulk of today's episode will be trying to figure out the canonical Huffman encoding stuff, which, again, there's a link available, or rather I will link it as we go to it. And there's some really cool stuff there that really helps out with the encoding of Huffman trees and stuff like that. Now, truth be told, I didn't quite figure out canonical Huffman coding as much as I wanted to, but that was because yesterday was kind of busy with work and all that kind of stuff. So I didn't really get as far as I wanted to there. So I'll try to get done most of it tomorrow, and today might be a bit of a shorter stream just because I don't have as much to cover. Basically today we'll be going through re-implementing some stuff in the Huffman.jl, figuring out how to do the decoding, and again we'll do it in a very simple way, like nothing complicated. And then after we do the decoding, we'll then go through, see if we can optimize the Huffman code as we have it set. Then we'll go back through and do some canonical Huffman stuff and go from there. So I promised yesterday that I would go through a basic update on how to do Huffman encoding and stuff like that, and I'll do that in just a bit. JSPP, I mean, I would probably look into it one time or another, but I'm not that into music and piano and so on. But I would try it for sure. I mean, what is he to lose? Yeah, that's true. I mean, the thing is, this guy has like over 100,000 subscribers on YouTube. It's like 132,000 subscribers or something like that. So it's actually very likely that he would do pretty well on a live streaming platform. Besides, I think that live streaming is, I don't know, it's one of those weird things. Like, live streaming is super beneficial for the streamer. I don't know how beneficial it is for the viewer. I think if the viewer enjoys it enough, yeah, sure, it's great. But I don't think live streaming, like watching live streams, is for everyone. But I do think that, like, as a streamer, live streaming is way, way better than making videos. It's just a much easier way to engage with your audience one-on-one, where you don't really get that opportunity when you're doing YouTube, right? Because with YouTube, you know, I was talking about this the other day. There's a lot of weird things, YouTube versus Twitch. I mean, Twitch is a community-focused organization, I guess you could say. I mean, you as an individual, the only way you can succeed on your own, people can find your stream and stuff like that, but really you can work with other streamers, and like you can host other streamers. There's ways to directly get people to watch streamers that you enjoy. With YouTube, that's not exactly the case. I mean, you can collaborate and stuff like that, but I don't know, it just feels more disconnected than Twitch. Twitch just feels like one cohesive, organized unit. YouTube kind of feels a little bit disjointed and hard to follow. But again, it kind of depends. The other thing too is that YouTube videos are typically focused around the YouTuber, whereas Twitch streams are usually focused around the community, or at least going with a community, like together to do something, you know? And it seems more fun and enjoyable because you're always focused on that community instead of being focused on yourself as an individual. And that's something I think I have learned from Twitch, because I think it's very useful. Okay, so that's all I'm going to do for rambling today. Let's go ahead and start by talking about Huffman encoding and go from there. So let's do Zernal, and then we're going to go ahead, open up Zernal. You guys know the bug. I'm going to have to open it up, close it, open it up again. That's perfectly okay. There we go. Okay, so Huffman encoding. Okay, so right now we'll just cover Huffman encoding, and we'll go back through and describe canonical Huffman encoding. Probably in 30 minutes or so after we finish the decoding function, maybe a little bit longer, maybe 45 minutes or something like that. So if you want to do something else, if you're only here for canonical Huffman encoding, feel free to come back in a bit. We're going to cover basic Huffman encoding first. Sorry about the yawn, guys. So basic Huffman encoding first, and then go from there. Hey Marin, what's up? I feel like it's been forever since you've been online, or at least maybe I'm just being very bad with pattern recognition here and you were on yesterday and I just forgot, but thanks for coming in, really appreciate it. So Huffman encoding. Huffman encoding is rather straightforward, right? So the idea is we have some string and we want to turn it into a bit string. Ho-ho, that's crazy. Yeah, it's not that crazy. Okay. So we have some string, we want to turn it into a bit string. Now, just as a bit of a forewarning, strings obviously in any programming language are already represented by some sort of bit string in some fashion, right? So in essence, we're taking some bits and we're compressing those bits into other bits. You know, like we're turning it into fewer bits. Yeah, I have a weird pattern. That's okay. How have you been? Okay, so now we have the string. We turn it into a bit string. Now the question is, how do we do this efficiently? Do this efficiently. Also, I guess I too have a bit of a weird pattern. Your mind doesn't fail you. That's a silly way to put it, but yeah. Okay, so the question is, how do we do this efficiently? Well, there's a bunch of different ways. The first way that you might imagine is just to take all of the characters that we have. So let's say we have A, B, C, and D, and just create some sort of list of code words for each of these guys. So A will be encoded as 0, 0, B will be encoded as 1, 0, C will be encoded as 0, 1, one of these days, and D will be 1, 1. Right, this will work just fine, no problems with this one. However, depending on the frequency of A and the frequency of D, and B and C, maybe you want to change the alphabet up. Maybe you want to change the book of code words so that you have fewer characters for A and very many characters for D. For example, if you have a string that's literally just A, B, C, D, you know, then like, let's remove one A, so it's out of 16. Then we have, like, you have, oh, what is this? This is going to be, how many A's here? 16 minus 3 is 13 out of 16 A's. 1 out of 16, 1 out of 16, 1 out of 16, right? So there's 16 characters in there, and 13 out of 16 are A's, 1 out of 16 is a B, 1 out of 16 is a C, 1 out of 16 is a D. It doesn't make sense to have A be the same length as all the other ones, because if you want to minimize the size of your output bit string, it would make more sense to have A have a shorter number of bits than the rest of the characters in the string, because it's used so frequently. You have a kind of better shortcut in order to use A when compared to the other alphabets. So that's kind of the idea here. We want to minimize the bit string out at the end. And again, there's a number of different ways to do this, but Huffman encoding is the one that ensures that you have a prefix-free code, first of all, which we'll talk about in just... Well, okay, so prefix-free code, which basically means that A is not within any of these other characters. So for example, if A was 0, like just 0, this alphabet would not be prefix-free because A is right here as a prefix for C. If A was 1, this would also not work because A is a prefix for B and D. So we need to create code words and codes that are not inherently held within other letters in our book of code words, if that makes sense. So that's one thing. Huffman encoding ensures that you do not run into this situation. And it also ensures that we have a minimal number of bits at the end. So we maximize our compression ratio according to some external, I guess, optimization character or something like that. Okay, so let's do new page before. Here's how it's done. In practice, it's not very difficult. What we do is we have our string that we want to encode. So this is going to be called 2-pass Huffman encoding. Encoding. The first pass is we go through our string once. So A, B, 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 C, C, D. That's our string. Okay? So we go through our string once and we figure out the frequencies of all the characters. So A is going to be 0.4, B is going to be 0.3, C is going to be 0.2, and D is going to be 0.1. So here we have our list of frequencies. Hey, Playing with Scissors, what's up? Just listening in the background while you're at work. Want to say hi, though? Hey, appreciate it. So I guess you must live somewhere in the US such that you are at work right now. So I would imagine it's probably, what, 4 in the afternoon, 3 in the afternoon, something like that. Somewhere between 4 in the afternoon and I want to say midday, 12. But that's cool. Thanks for coming in, man. Really appreciate it. Okay, so now we have this list of frequencies here. All we have to do to make an appropriate Huffman tree in order to encode is add 2 of the values of lowest frequency together. So now we have these 2 added together to be 0.3, these 2 guys added together to be 0.6, and then these 2 guys added together to be 1.0. From there we traverse back through the tree. Argentina, you told me that yesterday, and I totally forgot it was you that said you were from Argentina. I apologize for that. Should have remembered. Okay, so now what we do is we traverse back through the tree. So if we take a right hand turn, we add a 1. If we take a left hand turn, we add a 0. So 1, 0, 1, 0, 1, 0. This means that A, the alphabet character for A, or the book of code words, the code word for A is just 1, because we just have to go through that one branch. B will be 0, 1. C will be 0, 0, 1. And D will be 0, 0, 0. 0. 1 second. 0. There we go. So this is the idea then. We have A, B, C, and D, and they're created based on this Huffman tree. It's not particularly complicated, but code-wise it can be a little bit, it should be a little bit hard to create in code. JSPP, you should start a note file with information about viewers. I feel like that is borderline stalking in a way. Like, it'd be very weird if I just had a list, like, I don't know, some sort of internal, I don't know, spreadsheet or something with all the people's names and all of their characteristics next to it. I think that'd be kind of weird. But I do try to do my best to remember people when I can, you know? I don't get so many viewers on the Twitch stream. It's hard to keep track of everyone on YouTube, but on Twitch, you know, we have a few active viewers, and as the viewers come in and out, I usually try my best to keep track of everyone there. It's highly illegal in some countries. I mean, it depends, right? I mean, this is all information that has been freely provided to me as a streamer and to the community as part of this community. So it's probably okay. Since you must protect the said notebook. Oh, maybe. Okay, so here's the idea of two-pass Huffman encoding. We go through once, we find the frequencies, we then create the book of code words, then after creating the book of code words, we then go through and re-encode it. So in this case, we re-encode it as, first all the A's. So this means all the A's are just 1. So it's going to be 1, 1, 1, 1, followed by B's, which is going to be 0, 1, 0, 1, 0, 1, C's, which is 0, 0, 1, 0, 0, 1, and then D's, which is 0, 0, 0. And that's our final bit string. I think that's all there is to it. So this is Huffman encoding in a nutshell. It's super easy to do on paper. Obviously, you don't want to do it exclusively on paper, though, because if you're doing it exclusively on paper, you're never going to actually, like, encode anything real. It's just going to be, I don't know, just for fun on the side. And I mean, yeah, I'm not going to knock you. If you like just creating Huffman trees on the side with a small alphabet, cool. I mean, like, you do you, man. But the way I see it is we're probably going to want to implement this sometime in code. It just came to my mind since Adam has a file with the pronunciations of viewer names. Oh, I didn't, yeah, I guess that's fair enough. It seems weird to me. I don't know, so I've been streaming for a while now, and I realize, yeah, sure, I'm not consistent enough and all this kind of stuff, but the interaction between viewers and streamers is kind of unique to Twitch. Oh my gosh, I cannot speak today. My fault for getting up at 5 in the morning every morning. But anyway, the interaction between streamers and viewers is very unique to Twitch, and it's one of those things that it's nice to be able to pop in and be like, hey, welcome back. You know, I'm glad you're here. Rather than coming in and me being like, ah, man, I've got this list of facts about you. I remember that you're from Argentina and that you're 17 years old and happen to be female and happen to be located very close to me, like geographically. Like, it's kind of weird, you know? By the way, the 17 comment was not related to anyone who's actually watches my stream. Well, okay, 17 was, but the girl and very close geographically, none of that is related to anyone on stream. I'm just saying it could be considered creepy, like if something like this were to happen, you know? Is she single too? I mean, like, based on my data, I assume I could write a plugin that adds the country flag near the username. Yeah, I mean, you could. It wouldn't show up on IRSSI, but you definitely could. I just feel like, in certain cases, it's creepy, you know? Like, maybe I'm the only one, but I don't know if I necessarily would be comfortable with having, like, a list of everyone's name and, like, a list of qualifiers next to their name, you know? Like, if I just said, I don't know, this guy's from Germany, this guy's from, Great Britain, this is all fine. I don't see a problem with that, actually, because, I don't know, maybe it's okay. Maybe I'm just kind of screwing everything up. I could enhance Symbot to collect user information. If you do that, I'm unfortunately going to have to, like, stop allowing you to develop Symbot. I just feel like it's too much. It's too much. Asking for people's data or, like, keeping people's data without their information. Gustorn, thanks for coming in. Thanks to everyone for coming in, actually. So this is two-pass Huffman encoding in a nutshell. There's a couple of things to point out here that I pointed out on the first day. One is that there's a measure of the compression ratio itself, which is this factor L. L is basically going to be equal to a sum, I guess I'm just going to say I to N, where we go through all the characters in our book of code words. And the idea here is that we multiply the probability times the length of the code word. So I guess I'm just going to do code word of I. Notationally, this is something like this. So the probability of I and then the length of the code word of I. You put these guys together and you get some sort of common factor that you can use to measure the compressibility at the end. Gustorn, sure, if money trouble is there, we have things to sell. You're gonna sell people's data. Don't turn this into another Facebook. It's dishonest to begin with. You're to consider you should just follow Facebook's lead. Facebook. Good old Facebook. Good thing my family still uses it, so I can't quit. Honestly, though, I don't know about you guys, but I feel like I don't really use Facebook for Facebook itself. You know, I only really use it for the Messenger application. And so it kind of seems weird to me that people are still like playing Farmville on Facebook, and that you know, people can get data from such applications. And I'm not actually sure the whole controversy surrounding here. Like, I don't know from what applications Facebook took data from. Does that make sense? Like, does it store all data from like all Messenger, like messages, I guess? Or does it just take information from like apps and stuff? I wouldn't be Facebook. They still provide a service. Simbot wouldn't. That's true, I guess. I actually refuse to talk to family members on Facebook. Yeah. But what else do you make them use? I mean, everyone's on Facebook nowadays. I mean, if I don't have a cell phone, so there's no way for me to communicate with people across country borders. I mean, I guess there are. Like, we could use Google Plus or something like that. By the way, I switched my parents to Signal and no longer use WhatsApp. I don't even know what Signal is. It accesses whatever it wants since it has the permission to all the phone. Yeah, but I don't have a phone. So, like, I guess it just has access to anything I put on Facebook, right? Which I don't really put too much. I installed Wire. Works pretty well. I haven't actually even heard of Wire. So as a quick example, let's say we have the following case that we had before. So A is going to be 0.4, B is going to be 0.3, C is going to be 0.2, and D is going to be 0.1. And we have the following two alphabets. We have A as 0, 0, B as 0, 1, C as 1, 0, D as 1, 1, and then we have the other alphabet of 1, 0, 1, 0, 0, 1, 0, 0, 0. So these are the two different alphabets. L for the first case is going to be equal to 0.4 times, well, how about we do it this way? 2 times 0.4, 0.3, 0.2, 0.1, and then there are pluses between these guys. Sorry for that, that's notationally complicated. And then we have a 2 here. Okay, so L for the second alphabet, so that's L1, L2, is going to be equal to 0.4 plus 0.3 times 2 plus 0.2 times 3 plus 0.1 times 3, and it's going to be equal to 1.9. So in this case, the L value, 1.9. The L value for the second alphabet here is slightly smaller than the L for the other alphabet here. So that means that between the two of them, that time symbol, I'm sorry, what should I use for the time symbol? Like, what do you want me to use? I mean, I know that's like the convolutional symbol, but like if I do this, I guess that works okay, but that's a dot product. That's fine. We'll switch to that. The dot's okay. Yeah, dot there. Where are we? Dot there. Dot there. Okay, good. Anyway, the L value for the second alphabet is slightly smaller than the L value for this alphabet, so that means that this alphabet here is going to be, this alphabet here is slightly more compressed, so this is the better alphabet to use. And this is the one that we generated with Huffman Encoding, so we can see that we can generate kind of a better book of code words based on using Huffman Encoding. Okay, fine. Like, let's take a second, talk about multiplication symbols. Here's my problem. I'm not going to use this as a multiplication symbol because it looks like an X. This is also equal to a convolution. So convolution. So yeah, I understand that that's kind of weird. This works, but every once in a while I do it very quickly, and it looks like, you know, really messy, as was the case down here, where it kind of looks like a plus. So I guess this works, but it's a dot product. You know, like, I don't know. What multiplication symbol should I use? 1, 2, or 3? Or is there another one I should do? I mean, I could do this one. That one also works, I guess. But that one's definitely... Okay, let me know. Which multiplication symbol should I use? I like the dot, but yeah, it kind of sucks on the screen. Yeah. Okay, so we can use a dot from now on. Doesn't really matter. I always use dots on paper. Yeah, I usually do too, but it's just on the stream for some reason I always use the star. Just use the pen and press it once on the paper and lift it up again. No scribble, nothing. Perfect times symbol. That looks like a single pixel. So here's if I just press it down, that's our dot, and that's not very good either. You know, I mean, like, maybe it's okay. No, but that's like hardly visible. Oh, you know what I could do? I could increase the size here. No, that still doesn't help. I could decrease the size there. No, I don't know. Anyway, I'll take. Well, why can I not speak today? In the future, it'll be fine. Okay, so now let's go back through the Huffman encoding stuff. X into a circle. That means something else, though. That's like an outer product, right? Isn't it outer product or is it inner product? Shoot, I'm very bad at this. And if someone can't see the symbol, nothing at all means the usually multiplication as well. That's true, but if we have 0.3 times 2, meh, that looks like 0.3.2. Outer. Thanks. Yeah, okay, fine, whatever. I'll figure it out. We'll use big multiplication symbols from now on, just a dot, something like that. That, I guess, is a little bit better. Still not great. Okay, so let's go back to Huffman encoding. So we have some basic version of Huffman encoding up with Julia. Now again, as I mentioned before, Gustorn went ahead and wrote another version with Julia, which again is more efficient than my version, just because it always is more efficient than my version. So let's go ahead and cd into projects, Simuleos. Let's do the same thing over here, cd projects, Simuleos. That looks like 0 times 3.2. So it's just 0. Then you need to enhance the spacing. Anyway, just do whatever you want. Yeah, I'm sorry, I can't figure this one out. I'll just quit drawing multiplication symbols. From now on, I will creatively use... Oh, no, I will explicitly use addition from now on, instead of multiplication. So instead of doing 0.3 times 2, I'll just write 0.3 twice. And I think that's probably the most efficient way to do it. You need to enhance the spacing. It's actually not that efficient. Yeah, but I think you took... So, to be fair, you did a lot of things that I didn't do. So let me go into VI, Huffman dot... Oh, I'm not in Huffman. Let me go into Huffman.jl, Huffman.jl. Okay, so you did some things that I didn't do. So, and also your encoding and decoding I think is a little bit more efficient than mine. But I couldn't quite figure it out. So since you're here, maybe you could help me out with this one. We have insert or add, fine. Huffman tree, fine. But the thing I couldn't quite get is this gen codebook, the codebook recurse. I wasn't sure how this worked exactly. So you have function codebook gen, or gen codebook here, which is of type codebook, I guess. I guess syntactically I'm just having trouble. I mainly tried to do nice and compact functions. It's actually not that efficient. Yeah, I just couldn't quite figure out how that one worked. I like the codebook and the decode recurse. These are things that I couldn't quite figure out for some reason. But again, to be fair, I woke up at 4:30, right? And then I kind of like stumbled out of bed and then moved on and looked at the Twitch chat. And then I saw, after that, this code here, and I was like, oh, okay, well maybe I should take a look at it. So I haven't really looked at it too much and really haven't figured out how it worked. Same's true for the Rust code. I meant to look into it yesterday during work, but work ended up being very long and hard, so I didn't get as much done. Code recurse are local functions. I could have defined them as regular functions. Okay, I see. So we have some... Okay, I see. So to generate the tree... Okay, so rather than generating a codebook itself, let me see if I got this right. So rather than having a map that you've generated by recursing the tree, it looks like you... No, there's no way... Decode recurse. Yeah, I realize that this is just depth first search, but the question is, Where's your encoding and decoding map? So codebook recurse, result equals dictionary. Character string. Okay, so here's that. Then we do codebook recurse tree. Okay, I see. It's just the... Wait. It's just the depth first search? And then you said no. Oh no, it's a depth first search. But... What? Isn't that the same thing? Okay, so I think I get it now. You do some sort of depth first search in order to create the code words here. Then you have the dictionary here, which is a character and a string. You do codebook recurse. Let me see, where is codebook recurse? Oh, this guy up here. Okay, I still need to look into it a little bit more. With the decoding though, I think yours is going to be more efficient than mine. I actually hadn't really looked into how to do the decoding. I should have last night. No, it's good. It's good. I'm sorry about that. I should have. I always forget about the delay when talking to you guys, so I end up like asking a question and not waiting enough time for you guys to answer. It's an annoying habit of mine. I need to get better at that. Okay, so as far as my code is concerned, there's a few things I did want to look into with Julia today before really moving into the Huffman encoding with the canonical Huffman encoding stuff. So the first thing was actually the nullable type with Julia. So the way I have it set is kind of sort of similar to how Gustorn has it in here already. He's got a leaf and a branch, but he has a union of the leaf and the branch here. Whereas what I have over here is an abstract type, which I call binary tree, and just an empty node that's within the binary tree, so that the node itself, we don't have differentiation between the node and the, how do I put this? Between the node and the, like, leaf nodes. So within like an internal node and a leaf node, we don't have a differentiation in mind. However, the other note is that he just has a count, and he doesn't have the bit string that he carries along with him. And because the leaf node is always going to be the only one with a character in it, he doesn't have to carry a character around. He doesn't have to carry a character around with him. So that's kind of the idea there. I'm not the biggest fan of abstract types in Julia. Yeah, this is just the way I kind of made it a while ago. Julia 0.5 is when I did this. So quite frankly, it's probably changed and the landscape's probably different now. But I don't know, I think the typing system in Julia is actually quite robust. I'm not sure how it compiles down though. In fact, we should probably test that. So let's run Julia really quick. And let me think, how do we do this again? Let's go ahead and do include. Let's do, I don't know, what are we including here? It's going to be huffman.jl. And we're going to pop here. Okay, that one seems to work okay. So now we have all the functions, and I think, what is it? It is at code, what is it, code native? Oh, I'm really bad with the debugging, I forgot. Code native. Then I think we just run 2pass. 1 second, 2pass Huffman of, I guess we just read in the string here. Okay. I think this should generate, yeah, that generates the LLVM code. So now let's see, what else do we have here? We also have code warn type, but I think it's probably okay. So what we can do is we can actually check the LLVM code versus like of the two different types and see what works out best and which doesn't. But I assume Gustorn, you've probably already done that. So in that case, it's probably not too worthwhile. For the record, for people who don't know Julia very well, this is also one of the reasons I kind of like Julia a lot. It's super easy to find like debugging information and stuff. Oh, it's ASM. Wait, how do we get the? Oh, there is a code LLVM. 1 second. Yeah, there it is. Is that code LLVM? My bad. Code LLVM. That's what I was looking at. Yeah, okay. Cool. Yours is most likely worse, but I'll check. Well, I don't know. I'm not really sure. I mean, I'm pretty sure that yours is more like there's a lot of implementation details. You think ASM is easy to read? I'm not sure if I'm being honest. But anyway, one nice thing about Julia is that if you want to optimize your Julia code, there's very clear ways to do it. The main thing with Julia, like the main problem with Julia is like if you do anything in the global scope in Julia, it's going to be slower than if you wrap it into a function. So you always want to wrap it into a function if possible. There's a few other things that you can do to speed things up. Like for example, if you have any code or type instabilities, which basically means you wrote a type in and it's not, like if you wrote something in, like let's say you wrote 1.0. 1.0 is naturally a float in Julia. If you write 1, that could be a float or a double, and so it kind of reads it as two types at the same time. That's actually a bad example because I don't think it naturally does that. But some, like let's say you say, I don't know, what can you say here? Like you define A, and you don't really explicitly define the type for A. It'll kind of assume that you have some sort of abstract type, like some abstract number or something like that for A. And then as you go through, you might find that it doesn't know which type it's supposed to be, so it generates code for both types. And this is very slow. So like fixing these types of type instabilities, as they're called, this also increases your Julia code. For the most part, as long as everything's out of the global scope, and you've removed all your type instabilities, you're going to be pretty quick with Julia. There's a whole bunch of other ways to optimize it further, but usually Julia code isn't so tricky in terms of optimizations and stuff like that. Like it's not as hard to optimize as, for example, C++ or something like that. Playing with scissors, sure it's easy to get, but that looks pretty hard to understand. Yeah, the code itself is quite hard. Usually what you do is you'll have like two different code bases, and to be fair, usually I just look at the length or something like that. However, I do have a friend of mine who lives in, or who currently works for MIT and does like compiler optimization of Julia and all that kind of stuff. He's a pretty pro guy, and he looks at this stuff all the time. Like he just sees it and he's like, this is clearly what we're supposed to do. In fact, at OIST, sorry on the tangent here, but at OIST we have these kind of short lecture courses, I guess intensive problem-based courses or whatever. I don't really know how to call them, but they're called skill pills. And the idea is that we teach a particular topic in a very short amount of time. So we had a skill pill on the Julia programming language. And in the skill pill, it was taught by my friend, who is now at MIT. And man, he, in the first day, like at first sight, we were like, okay, this is a Julia skill pill. We're going to teach it to people who already know programming. The problem was a lot of people who came in didn't already know programming or didn't know it so well. And so we went in and we immediately started talking about how to optimize Julia, how to do all this kind of stuff with Julia. And we didn't really talk about how to just use it as a programming language because the assumption was that everyone already knew how to code. And so we basically like on the third day, we had a problem set. Like the whole point of the third day of the skill pill was a problem set. And that was like the first time people were like, okay, so now how do we compile Julia code? And we were like, we showed you that on the first day. I assumed that you would understand how to use it pretty straightforwardly. So anyway, we overshot what we thought people could understand by a significant margin. And it was kind of funny because I really enjoyed it, but the module system, yeah, there's actually a lot of problems with Julia. Like you run into more and more as you go along. But ultimately, I mean, I have problems with every language, you know, and Julia fixes a lot of the problems I have. I don't know. Again, it's not like Haskell. It's relatively straightforward. Besides, object-oriented programming, in my opinion, it's complicated. It's ugly. It's messy. I mean, there are some situations where it's definitely warranted. Don't get me wrong, but for the most part, I think that people who use very heavily object-oriented code, I mean, it's just messier, you know, in a lot of cases. But there's a lot of cases where it's not, you know, you just go back and forth. For me, I tend to find like having a function that acts on a type is easier for me to think about than a type that has a function within it. You know what I mean? But this is my own personal preference. A lot of other people think differently. And then there's always this huge debate between functional and object-oriented programming anyway, so it's okay. Okay, so what I need to do now, and I'll go back through and talk about this type stuff in just a bit. What I need to do now is put in a decoding function. And the reason I've been dilly-dallying on this one is because I didn't actually look up the best way to do this. So, my apologies on that one. Let me go ahead and get a quick sip of water. I mean, in essence, and this is going to sound really dumb, you guys feel free to tell me the best way to do this. We have a code book, which basically takes a single character, like A, B, C, D, and puts it into a bit string of 0, 1, 0, 0, whatever you want the bit string to be. So in principle, decoding should be going through the bit string, right? And turning it back into characters. So we should be able to find some way in order to flip the codebook around and find our decoding that way. Now this isn't the most efficient way to do it. I know that's not the case. Canonical Huffman encoding actually has a dramatically different way to do this, which we'll talk about in just a second. But for now, I think we'll just do this the straightforward way. So what I want to do is very quickly look at something over here. So I'm going to create a dictionary in Julia. So we're just going to say x is going to equal to dictionary. I don't think you can without going character by character. The electronic codebook is the tree. Yep, that's true. But that's why I was thinking maybe what we should do is just... Yeah. We flipped around the codebook. Hey, lolly lol, what's up, man? Okay, so how did you do it, Gustorun? This is the thing, I didn't really look into it as much as I should have. And I know I didn't, and I should have. I apologize for that. So we're going to say we have a dictionary between, let's say, a character and a string. And we don't put anything in it for now. Now what we're going to say is x of... that was a dumb name for a map, but that's okay. That's what we have. X of x. I'm sorry. 0, 1. Something like this. And we're going to say y. Sorry, I'm just giving it some random things. Z. Now let me just do x of 1. Yeah, dang it. I thought I could access it in some other way, but I can't, obviously, because it's a dictionary. I just thought maybe the way that Julia stored it underneath was a bit different. Okay, so let me see what you guys did, what you did over here. The decoder in my implementation, you can look at it. Yeah, that's the thing, I couldn't figure it out. Because of the way it's written, like, it's kind of boggling my mind real quick. Like, so we have the decode recurse, which has the leaf. Yep, I can't quite read it. So we have function decode, which returns a string, that's fine. Basically goes character by character, and follow the respective branches until it reaches a leaf. Oh, I see. Yeah, okay. I like that idea. So we have the tree anyway. So if we just read in the Huffman tree, but isn't it more efficient to... You shouldn't use fake data to decode it? Oh, yeah, I know. I get that. But isn't it more efficient to just create a map? Like a reverse map? I guess you're going to have to go through character by character real quick. Okay, so here's the idea. Let me go... new page before. So what I was going to say is the following. So the depth first search on the tree to generate the map, is it more efficient? You probably shouldn't use fake data to decode it, even when just messing around in live. I don't quite know if I understand what you mean by playing with scissors. You probably shouldn't use fake data to decode it, even when just messing around live. Yeah, that was just me messing around with the dictionary real quick, so I was just checking something. Okay. So let me see, what do I want here? So we have some sort of tree. Let's do, here we have the central node, we have 0, 1, another node, 0, 1, 0, 1. Okay, so here's our Huffman tree. Let's say 0, 1, 0, 1, 0, 1, oh, 1, okay. So we go to the left, it's 0, go to the right, it's 1. That's our tree. Yeah, again, I was just testing something. I don't know exactly what you mean. I was just creating a dictionary to see how it worked in Julia. And x is just a variable. I mean, it's not like we're ever going to see that variable again. Okay, so if my understanding of what you're saying is correct, Gustorun, the idea is like if we get 0, 1, 0, 1, 1, 1, 0, 0, 1, 1, 1, 1, or something like this, then you just say, okay, so we go here, here, and then let's say it's A, B, C, D. You just go through, oh, that does not look right. There and there. Then what we do is we just say, okay, so 0, 1, so we say B, 0, 1, B again, 1, 1, which is going to be D, 0, 0, which is going to be A, then we have D and D again. But every time you go through the tree. Okay, so you're saying because we're traversing the tree every time, it's actually more efficient than if we were to create a map. Because I feel like if we had a map of like the opposite of the other map, but you could flatten the tree into an array, and it's still a binary search with a better data structure. Yeah, what I was thinking about was putting it into another map, but maybe this is better. So if we had a map instead, where the map was just like, so it'd be 0, 0 reads in A, and 0, 1 reads in B, and 1, 0 reads in C, and 1, 1 reads in D, right? Is this not the same thing? So if we just like, I'm sorry, I'm being really dumb here. That's easy because every character takes the same amount of bits. I mean, even if it doesn't though. Like, let's say we have the following alphabet, page, new page before. So if we have the following alphabet, so like we had before, it was 1, 0, 1, 0, 0, 1, 0, 0, 0. That was our alphabet. And again, I'm just going to put some arbitrary characters out here. So it's going to be A, B, C, and D. So let's say we have the following code, 1, 1, 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 1, or something like this. If we have the map, like we said before, then we just go through. It's like, well, that's clearly A, that's clearly A, that's clearly A. This guy, we don't know what this guy is yet, but then we add a second character to the string, and then we know it's B. And then we do this one, we don't know what this one is, we don't know what that one is. We add a third character and it's C. We don't know, we add the third character and it's D, so on and so forth. And then these last ones will be A, immediately decoded. Right? So, okay, I can clearly see how this could be inefficient, because this would mean that if we, because this would mean that if we don't know what this character is, so that means we have to search through the entire map. And that's not efficient. The clearly it's A thing is fine because the map clearly says this is A. But yeah, exactly. That's what I was saying, Marion. We just read bit by bit until we find the appropriate character. But I think I see what Gustorin and Playing with Scissors are saying here, in that if we search bit by bit, like through our map, then we have to go through the entire map every time. And this isn't really going to be good. So it's like, does this value exist in the map? The answer is no, and then we move on to the next one. Right, like algorithmically, I mean, or in code, this would just basically look like, what do we say? So we're saying, let's call this the code book. Like, we look for code book of basically 0, right? And that doesn't exist. So then we do codebook of 0, 0, right? And then that one doesn't exist. And then we do codebook of 0, 0, 1, and then that one does exist, so we're good. But since these values don't exist, we have to kind of iterate through, and it's going to be kind of a pain. Okay, fine. So if we use a tree instead, which is also a pretty good way to do it. Yeah, we can do it that way. So then we just iterate through until we find a leaf node. And then once we find a leaf node, we go from there. If you interrogate the map after each bit, and that's not effective. You need to travel until you don't get a character, then you go back and make the current stream -1 characters in stream. And with some, yeah. So I think you guys are right. Just have to think about it. You interrogate the map after each bit, and that's not effective. Yeah, that's exactly correct. Okay, good. So let's go ahead and do it with the tree. That should be okay. Shouldn't take too long to implement since we already have the tree anyway and we've returned it. So let's pop down here. So for decode, what I want to do is just read in the tree. So let's see, we have the bit string. We definitely still need that guy. But here what I want to do is read in the Huffman tree. So I'm going to say Huffman tree, which is going to be in my implementation of type node. So now we have the Huffman tree in here. We have decode. I guess the idea is that we have some sort of recursive decoding function in here that goes through the tree and basically goes left and right and left and right and just keeps going through the tree in that way. So let me think about the best way to do this. So we do have the bit string, which is good. And we know which direction we need to go. So I guess all we have to do is take the bit string and then basically that's going to be the future directions in which we go. So for example, if it's 0, we go left. If it's right, we go 0. What? If it's 0, we go left. If it's 1, we go right. There we go. That's what I meant to say. Okay. Now, let's see. What's the best way to do this? So since we have like all of the different directions, we can kind of put that into a queue, and we can pop those directions as we go along. That way we have a single data structure that we read into a recursive depth first search problem every time. That's relatively straightforward to use. I'm just afraid about using like a linear structure with recursion. You know, every time I try something recursive, it ends up being kind of finicky here. So let me think. Is there a way to do this? We have the string. Let me just start writing some things really quick, and it's going to look ugly for a bit, but let me try some things out. So while, I guess we'll say for I in bit string. So this is going to be our directions. And yeah, this isn't going to work. Let me think. We also have let me think. Just made the implementation simpler, so I went with it. Yeah, I think you're correct in that the implementation will be simpler with it. So let me see what you have over here. We have leaf, input string, branch, input string. I see. So we have decode recurse, and if you're reading in a branch, we go left to right. If you're reading in a leaf, we just read out the leaf character. Okay. And then we have to read in the input here, which is going to be 2 to the end. That's about what I expected. Yep. Good. That makes sense. So what I was thinking about doing was, instead of having a string that we're reading in and keep having to do a substring, you know what I'm saying? So, page new, page before. So what I was thinking was, since we have this string, right, now I'm just going to put an arbitrary string of characters. So it's going to be 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 1, 1. I don't know, just this is what we have as our string, right? So this corresponds to going like left, right, left, left, right, left, 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 right, 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 right in our tree. And obviously every time we get to a leaf node, we basically say, okay, we're at a leaf node, we stop recursing at this point, take out the leaf node, that's our character, and then we go back up to the top. Now, one way to do this obviously is to go one space and then take this as a substring, right? You know what I'm saying? So first we go left, and then we basically read the rest of the string in, and then we go right, and then we read the rest of the string, and then we go left again and read the rest of the string in. Random right and wrong turns. Yeah, I feel like this could go wrong pretty quickly. But if instead of keeping this as a string, if we keep it as a queue or a stack or something that we can easily pop, I guess this is an optimization. It's not really going to be that much of a difference in the end, because ultimately it's the same thing either way. Okay, so let's go through and let's see what we have. So we have some sort of node tree, or some sort of node of our tree. So we have the node. In our case, we just have the single node, and we can tell if it's a leaf node simply by whether it doesn't have children or not. I realize that's not the most efficient way to do it, so we'll worry about making that a little bit more efficient in just a bit. I think Gusthorn's solution of having leaf and children nodes, or leaf and branch nodes, are probably pretty good. So we have in here the node, we have left and we have right. We don't have any parents. So, yeah, the recursive solution I think is probably the best one. So I'll go ahead and try to implement that here too. Don't you need a temp variable, the tree, and a string? What would the temp variable be holding? Oh, I see what you're saying. Yeah, okay, in principle you could. So you say we have a node. We have node temp. Temp. Which is the current guy. And so we say, I guess if 0, then temp equals node dot left, and then else temp equals node dot right, something like this. And so that's our if else statement. And then in both cases, if temp has no children, we're good to go. Temp equals number of zeros. And if another zero, wait, what? Temp equals number of zeros. If another zero equals temp plus plus, else temp equals 0. I was also talking about for decoding. Okay, here, let me try this. This is going to be really dumb, but let me give it a shot. Open link. Decode function result current equals node. Okay. For bit in bit string. Yeah, that's exactly, yep, this is exactly what I was going to say. So node is branch and bit equals 0. Yep, then we go left, right, exactly. So this is the temp thing that I thought JSPP was mentioning, but now I realize JSPP was mentioning something different. But yeah, we'll go with this one. I think this is probably the best way to do it. Or the easiest implementation that I see. Now, Gust1 obviously has another implementation that's recursive. I don't know which one's more efficient, if I'm being honest. This is something that we should probably look into. So we're going to say current is going to be equal to node, as we have it set node. And then we go in here and we basically say if I equals 0. Should be a character. Else and so if this is equal to 0, then we say current is equal to node dot right. Left. What is tail call elimination? Sorry about that. So let's see, let's go up here and make sure I'm going the right way. So if type of, so this song every time, I'm sorry guys. Mine would probably be good in Haskell or Erlang. Yeah, sorry about that JSPP. I apologize for not being clear. So we have type of temp left equals empty, type of left bit string. So if we go left, it's a 0. If we go right, it's a 1. Okay. So let's go here and we're going to say left is going to be 0 and right is going to be 1. This song is really dumb. I'm sorry. I have like a whole bunch of different songs on kind of like, I guess, shuffle. And so every once in a while you just get a weird song. Okay, so now we have I equals 0, which means if it's equal to 1, we should do this guy in here. So what we're going to say now is if there are children, tail call elimination is an optimization that can convert a specific kind of recursive function into an iterative one. Oh, yeah, fair enough. I think I've heard about this actually before. Let me get some more water and then we'll keep working on this one. Man, I'm just out of it today. I apologize for that one. I'm out of it like every day. You're right, I don't need parentheses around the if, but it makes me feel more comfortable. You know? Like, I understand it, but... Okay, so current equals node.left, node.right. Okay, so now what you have over here is you saying if the node is a branch, we go left, and if it's a leaf, we go forward. And that's correct. So what I was going to do is I was going to check it up here and say... So we're going to say if... and I'm just going to check to see if it has any children. This is going to be my way to see if it has, if it is a leaf node or not. So we're going to say current dot left equals empty, and current dot right equals empty, and then we just say the following. And we're going to say, let's see, we're going to append a string to the bit string. So now we're going to say final string. It's going to be equal to, what am I going to call it? I guess I'm going to call it string, final string, with either a 0 or a 1. Oh, no, with the character itself. So it's going to be current dot key. Something like this. Wait a minute, how do we add a character to a string in Julia? That's going to give us a problem, but that's okay. So then we just reset it at the start. So if we've traversed down to a leaf node, then we go back to the start. And then we just go through to the next I. Something like this should be more than suitable. So now we go up here and we say final string. Something like this. Oh, final string times current key? Oh, interesting. I did not know that. Learn something new every day. Okay, so now what's the problem here? So going through every I in bit string, then we should just have the final string. So let's just go ahead and return final string. See what happens there. And in principle, that's what string concatenation is. Okay, so let's go ahead and also fix all these guys up here because I'm an idiot. I'm so sorry. So in principle, this should work up here too. And you need a continue in that if. This if down here. Wait, why do I need a continue in this if? I think I don't want to continue, right? Okay. Let me go over here and let me just real quickly Control D, run Julia Huffman.jl. Okay, now let's go down here. Since we have the bit string, let's just go down here and say decode Huffman tree. Yeah, no, that's correct. And then we want the bit string. Julia Huffman tree. Good. Great. Node not defined. That's because I think I called it just Huffman tree. Because that's my bad. I probably should have called this something different. Current equals Huffman tree. Node not defined. Where did it? Current is equal to current.left. Oh. And then we have current. Okay, let's keep going. Empty, has no field left. Dang, okay, wait, you're right. So what we're saying then is... Wait, no, that doesn't make any sense. So we're saying if the current.left is empty and the current.right is empty, so this means we are a child, then we say the final string is going to be equal to a concatenation of the final string and the current key, and that should be fine. Then we say that current is equal to Huffman tree, which should bring us back to the top, right? Because that's where we've defined our top node. So now my question is, why is it saying empty has no field left? Because that means that our current node is empty. But that doesn't make any sense, because we should have been brought back up. Okay. So maybe we should output something else. So for I in bit string, current.left, current.right is empty. Well, let's just take a look here. Empty of current. Node, empty. I think I can also print I. Let's see, node 0. So it's going 0, 0, 1, 0, 0, and then it's empty. Oh, how about I just do something really dumb here? I'm sorry. I probably shouldn't do this whole like print decoding thing, but meh. Let me just do a very quick print line. Current dot key. And let's do juliahuffman.jl. Backtrace, empty has no field. Yep, okay, so that's the problem. We never go into this if statement. So if current.left is an empty and current.right is an empty, but I think the reason it's not going to this if statement is because I'm doing this incorrectly. I think it should be like type of. Yep, that's my problem. Because I'm an idiot. 1 second. Now, because of all these type checks, I've got a feeling it's probably not that efficient, this method. So we should probably find a better way to do this. So let's go ahead and run juliahuffman.jl. Okay, well it says hell. Maybe... Oh, I think I know the problem. 2pass Huffman. Let's do bitstring decode. So we're going to say final string. And we're just going to... oh, I probably need an equals there. We're just going to yank and paste and do final string. juliahuffman.jl. Ah, it still says hell, but I think it should be hello. Yeah, it should definitely be hello. Shoot. So why what the hello? What is happening? Okay, so why isn't it recursing all the way through the tree, or wasn't it going through the whole tree? I'm actually not sure. So we have the bit string here. The 0 should be at the end. Should be fine. Oh, I see. Because this... I see. Is there an isNull function? That was something we were looking into a second ago. There's a nullable type that we can use, but there isn't like an isNull thing that I could find. Yeah, I can do the nullable type. I didn't do it in this way. I have like an empty node, is what I put in there. So again, it's kind of a messy implementation that I wanted to talk about in just a bit. Okay, so we have final string concatenated with current.key. That seems fine. But the problem is that this should go under those guys. So if we do D5D and we paste it down here, now we should be good. Hello, great. Fantastic. So now we have an encoder and a decoder, which is perfectly not efficient, but that's okay. Yeah, so as far as the nullable is concerned, the reason I didn't do it yesterday is because I didn't quite know how to implement it correctly with the nullable type. In principle, it's like you just create like a nullable node or something like this, and then you can choose between like a null type and a node or something like this. I'm not really sure how that works. So that was something I need to look up. So that's how we are. That's where we are there. Okay, so we do have a decoding kind of working. Seems okay. Just to make sure we have something that is working relatively okay, let me pop down here and let me just add in this guy. Oh, let's do CC. And let's do juliahuffman.jl. Yep, okay, encodes, decodes just fine. It's just nullable node, and if you want to have a value, you just pass the value. So it's naturally null is the thing. Let me open up Julia, and let's look for an is null. Oh, is null exists? Okay, so let's try something then. Ah, okay, so that was my problem. Okay, forgive me, I know this is going to be a dumb way to say it, but if you want null, you just do nullable. Okay, let's see what happens. So in principle then, let me go ahead and commit what we have, because we do have a working encoding and decoding version, and then let's play around with it. So let's do git add huffman.jl, and let's do git commit -m, adding working decoder to Huffman Julia version. Yep, Git push. Origin master. Oh, come on, dog. There we go. Okay, now let's go into Huffman.jl. In principle, if we have the nullable type, we should be able to get rid of the we should be able to get rid of the abstract binary tree type entirely. While I'm at it, let me go ahead and remove all of these string functions I have in here, now that I know that there's a concatenation guy that we can use. Man, I have the hiccups, and I'm sorry about that. So let me just get rid of all these guys too while we're at it and make sure this works. I mean, it should. I'm just... There we go. Where else do we have it? Temp string I should be okay. Let me just look for string. Yep, that's the only one. Go over here, run a very quick Control D, and then juliahuffman.jl. Yep, still works just fine. Okay, so now let's try the knowable type. Okay, so in this case, I don't need the abstract type. I can remove that. And these guys are just going to be nullable nodes. So type node, and here it's going to be nullable node. Same thing here. Okay, so we have two nullable nodes, and then every time I would put in an empty, I just check is null. Yep, so let's go ahead and check all those guys. So all we do is null here, and remove this guy down here, and same thing down here. Yep. Same thing here. And here. Let's see. I think I'm going to very quickly do a $$ here and paste it there. And DD there. So if is null, this means that we have a leaf node. And if is null temp.right, so if these guys are not null, then we go left and we go right. Okay, so now we have to go down here, fix all these empties. So basically temp node here, I guess we just write nullables instead of the empties. In fact, every time I see empty, I just have to replace it with something. So let's go here and change this to nullable and nullable. Okay, what else do we have? Empty, empty, empty. If, yes, so these are the is nulls. So if is null, come on, dog. Is null here. Great. Is there another empty that I missed? No, looks like I got them all. Let's pop over here, juliahuffman.jl. Nullable has no field bit string. That's fair enough. Let's see where that one is. 23. Temp left bit string, temp bit string. Ah, I see. So wait, no. If it's not is null, I might have got my logic mixed up here. So is null, temp.left. So if temp.left, if temp.left is not nullable, so that means there is a left, then we say temp.left.bitstring is equal to temp bitstring with the 0. Huh. And it's saying here that for some reason this is hitting a nullable node, so type nullable has no field bitstring. Okay, so then the question is, hey Slayerdar, thanks for coming in, man. Okay, let's see, what do we have here? So I think, oh, also, it is 6:15 in the morning. Hey, CSE Meek. I'm doing great, how are you? So as far as the rest of today's schedule is concerned, I think we'll finish up this nullable stuff, see how it works, see if we like it better than the abstract types, And then from there, we will probably take a look at the canonical Huffman stuff, but only just how to take a Huffman codebook and turn it into a canonical codebook. And then tomorrow we'll talk about how to start straight from the canonical Huffman encoding scheme, like how to do the canonical Huffman algorithm. Let me think, what else do I want to talk about? So this might mean that I can't quite get the Huffman stuff out this weekend. It might not be until next weekend. Again, this is perfectly fine. My new upload schedule is basically when it's ready. So whenever I feel like this is ready to go, we'll put it up. Again, I don't mind moving a little bit slower, especially because I'm working on it part-time. That's great to hear. 8 hours time difference between you and I. Feels bad, man. Wait a minute. 8 hours. Where are you 8 hours different? So you must be at somewhere in Europe, right? You've told me before, I think, where you are. 6:15. So if you're 8 hours different, 8 hours forward. I feel like 8 hours is weird. Is it not weird? Oh, maybe you're in California, right? Okay, I don't know. I'm sorry, I'm not very good with the time zones. I've been trying to get better, but I can't. Okay, so here's the thing. While length of s is greater than 0, so we basically have a stack that we're iterating through, or popping through, or you know what I mean. So if is null, temp.left. So that means if the left node exists. That's what I'm trying to say here. Let me check something real quick. So I'm going to open up Julia. I'm just going to create n equals nullable here. And I would just want to say is null of n. Should be true. And then obviously put an exclamation mark on there. False. UK tag. Nabbit. I'm always bad at this. Because actually in principle, the US would be 16 hours behind, right? Something like this. I have 7 hours. Good, 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 good. I didn't realize it was so short. For some reason, because all the chat in Discord usually happens when I'm sleeping, so it tends to be that these discussions I don't really get to participate in, because like for some reason everyone is awake when I'm sleeping, and I'm sleeping when everyone's awake. But it's usually okay. So is null. So if the left node doesn't exist, that means there is no left node. This should return true, and then it will return false because of the exclamation mark. So if there is no left node, then we say temp. I don't know. I don't know. I assumed you were awake for all 24 hours. I'm not that efficient. I can guarantee you that. Although I don't sleep as much as normal people do, apparently. I only sleep for 6 hours. Sometimes less, sometimes more. It depends. But I think Gustorn's the same way. He said that he only sleeps for like 4 hours, sometimes every night. Last night I got a particularly good night of sleep. I don't know why. I guess it was because the night before I got a particularly bad night of sleep. Not really sure how that goes. Every once in a while, my roommate, like, he goes to bed at like, I don't know, like 2 in the morning or something like this. And I get up at like anywhere from 3 to 5 in the morning. So sometimes he'll just wake up at like 2 in the morning and I'll be like, fine, I'll get up now. You know what I mean? I thought you were a robot. Actually, I do get that one a lot, and I'm not exactly sure why. People, for some reason, think I'm not, you know, human or whatever. Gustor probably sets like 15 alarm clocks. Could be. Okay, let's see if I can figure this one out. So we have temp pop s. If the left node exists, then we should say that we concatenate. We should concatenate left bit string equals temp left bit string 0. And then we push the left node. Temp left bit string equals temp dot bit string times 0. Let me just, I don't know what to do. Apparently you need a get? What do you mean a get? Get temp bit string times 0. Wait, I just checked this, didn't I? Like this was working with the... Okay. What's the error that we're having here? Noble has no field bit string. Well, let's see what happens. I don't think this will necessarily solve the problem, but we'll see how it goes, because maybe it will. Ah, there we are. Let's just Control D, run juliahuffman.jl. Yeah, it's still giving me, whoa, this is different. Get at associate. Okay, now I don't know what this is. No method matching get string. Don't worry about it. Well, I like to believe that you're not human. Sure, you do what you need to do to cope with the reality of things. James probably hibernates in one of those capsule hotel beds. Man, I wish. Those sound amazing. Sorry to be silent, just ultra tired and sleep. Don't worry, man. Everyone gets tired. Plus the font is really too small for me. I can't really make the font much bigger. I mean, I guess I could remove the chat entirely, but I like having the chat on stream, you know? It's one of those things I appreciate a good bit. Okay, get temp.left.bitstring equals temp.bitstring 0. Temp.left.bit. Okay, wait, let me see. What does the get do? I'm not actually sure. But why do we need this? So let's just do get temp.left. And let's run juliahuffman.jl. Expression starting, let's see. Can I convert an object of type nullable to an object of type node? This may have originated from a call from constructor node, since the type constructors fall back to convert methods. Okay. Please remove the chat from stream. I feel like I don't want to do that. So I think the problem is how we're initializing this guy. So what we say is so we're creating the tree. We say weights is equal to a priority queue here. Fine, fair enough. We go through, we do all that kind of stuff. Nodes are then going to be equal to a priority queue that we're going to put into the queue together for the Huffman encoding. While the length of the weights is greater than 0, we create some sort of temp node, which is of nullable weight key. Yeah. Okay, I'm going to try at it for the next 5-10 minutes, something like that, until 6:30. So I guess 8 minutes. And then if it's not working by 8:30, we'll just go back to the previous method, which we know is working with the abstract types. And in that case, we'll just talk a bit about canonical Huffman encoding and how to convert a standard Huffman map into a canonical Huffman map or a Huffman codebook. And then from there, we will talk about the canonical Huffman encoding tomorrow. There is probably some inefficiencies in how I'm doing things. In fact, I know that there are inefficiencies in how I'm doing things. But we work with what we have, and then we'll take a look at the is null stuff again at some point in the future, because I think the nullable thing is more standard for different languages. Like, I think it's clearer for different languages, but I'm not really sure. So let's see, what's the problem here? So the problem is that we are, for some reason, we're going into a nullable node for some reason, but I don't understand how. Temp.left.bitstring. So what it's saying is, what it's saying is that temp.left is a nullable, right? So this means it is a null object. Yes, so type nullable has no field bitstring. That is correct. So it's saying temp.left is a nullable object. But we just said if it's not a nullable object, right? Maybe I'm reading this wrong, but if it's nullable, right? Then we put an exclamation mark. So if it's not nullable, we go into temp.left. Come on, what am I doing wrong here? CSK Meek, so you're a physicist before a programmer. Yeah, in principle, I am a physics PhD student at the Okinawa Institute of Science and Technology. So my primary occupation is that of a physicist, not necessarily a programmer. That said, I have plenty of interest, obviously, in computer science and stuff like that. And kind of the point of this stream is so that I always have time, or I always take time every day to learn about, algorithms and methods and things that I'm very interested in computer science. So this is more of like, I guess you could call it a passion project than it is an occupation. Now, as far as my job is concerned, I do kind of want to move more into like the computational side of things after my PhD is done. So maybe that's how it goes. But for now, yeah, physics is my primary occupation, I guess you could say. But again, it's a PhD student, so I'm still kind of in school. My PhD should be done in about a year from now, I think. So we'll see how that goes. Temp is null, temp.left. Nullable has no field, bit string. Okay, let me just do something stupid here. I'm gonna output type of let's see, temp.left. Make that. No, I'm sorry. Julia Huffman.jl. Nullable. It's already a nullable. Why is it already nullable? What? Let me type of temp. It says node and then nullable. The heck? I don't understand. Thanks for the answer. Thanks for asking the question, man. You're great. Okay, so nullable has no field, bit string. So what it's saying is that the type of the node is obviously node, but for some reason... Okay, screw it. Left. And let's go juliahuffman.jl. Yeah, so it's node, and then both the left and the right are automatically nullable. So that's a bit of a problem, and not exactly what we want. So let's see, why is that the case? So that means that left and right are naturally nullable, even though, so while length of weights is greater than 0, so this means we have the list of weights that we're going through. We say weight.peak, key dq weights, temp node is equal to node, and then we enqueue the nodes, temp node, and weight. See what we have. Struct leaf. Let's see, would it work without? Let's see, we have leaf. Yeah, I think we can do this. Left and right are nodes too, so they're nullable. They can all be leaves. Not sure why that's a problem. Yeah, okay, we can use the union. That should probably be okay. Let's see, is branch. Wait, what is this doing? Union leaf branch, constant node. My question though is the union or the abstract type more like, I guess you could say canonically Julia, you know what I mean? Like, which one should we go for as a Julia programmer? I guess they're both decent solutions. And I guess union would be cleaner for implementations in other languages. Yeah, okay. That's okay. So with the nullable thing, is the nullable thing also... No, I like the union solution better than the nullable anyway. Okay, so let's see if we can get this one done. So in this case, we create two different types. And I think you use structs, but that's okay. So struct. And we're going to say leaf. And we're also going to say end. And then we also have, let's go in here. No idea, I don't know Julia. That's fair enough. So let's say struct leaf, and what do we need in here? We need a key, which is going to be a string. And we don't need a weight in this one. Wait, what else do we need in leaf? I guess we need bit string and weight. Yeah. I'm sorry about that. Every once in a while, I sneeze. Okay, here. You're correct. Thank you. So let's go down here and let's do struct. And let's do branch. And in here, we just grab all the guys we have over there. So yank by yank, paste. Yeah, so if the type is if type is deprecated, then I'm pretty sure they want us to use structs instead with the union and everything. Yeah, I think I do need print string. I'll check it in just a second. So left and right are union of leaf and branch. Oh, wait, what? Yes. Union of leaf and branch. Yeah, my implementation is kind of silly there. So let's do union of leaf and branch. There we go. And do the same thing down there. And now what we do in the end is we say some sort of type def, but I think it's going to be struct node. It's going to be equal to union of leaf and branch. Something like this, right? Oh, constant node. Yeah, it should be okay. X. Oh. Because it's a global. Okay, so now we have the node. Yeah, thanks, Gustorn. Okay, so now the question is, what do these other guys do? So we have isBranch equals true, and so we read in a branch. Oh, okay. So isBranch other t, where t. What does this guy do? Here. Let's pop over here real quick. This is okay. So basically we have two overloaded functions. One basically says, hey, if we're reading in a branch, it's automatically true. The other says if we're reading in literally any other type, it's equal to false. This where t thing, though, I'm not sure exactly what that one does. Let me check this real quick. Yeah, I just didn't know what the where t thing does. T, so let's just do, I don't know, number. Dang it. Vector syntax is discounted. Let's do float 64. What does where to? I could, but I'm trying to figure out this where thing here, because it's fine either way. As a new way of writing generic parameters. Oh, okay, I see. So it's like some sort of template type of guy. Okay, so let's go down here. Let's go ahead and fix everything else up. This might take a little bit longer than I expected, but that's okay. Dictionary, what do we have here? Type of, let's go ahead and remove these guys. And basically what we want to say is here, all these guys is branch and temp.left. Okay, so if it's a branch, branch, yep, correct. And then down here we say is leaf. If, this is slightly different. Oh, you. This is going to be is branch temp. Okay, let me think. How do we do this? So wait a minute. No, I think what I can do. If is branch temp.left. Temp.left bit string, we add a 0. Yeah, let me do. So I don't think I need those checks anymore. Yeah, I think this should be okay. Because now we know if it's a branch or a leaf, so we should be able to tell pretty clearly. Create tree. This is where things get complicated. Okay, so we have haskey temp.node. Node, how do we initialize a node? Node is initialized as... Wait, how do we initialize the node? I think you have it in your code over here, don't you? So let me think. What do we have here? Recurse. Oh no, you naturally. Okay, so how do I make sure it's a branch? You only need to check if temp is a branch. Wait. No, I only have to check if it's a leaf. I don't need to. I don't really care if it's a branch. Right? Why would I care if it's a branch? Let me think. So we have temp equals pop s, sure. I'll check it one more time. Exactly, that's what I'm saying. So we check to see if it's... Oh, I see. So you're saying do this. Yeah, okay, fine. Fair enough. Something like that. All you have to do is push as far as you can. That's true, but I think this is probably safer in the end. So we check to see if it's a branch. If it is a branch, then we go ahead and add. Yeah, this is kind of how I'm doing it. So this is a bit of a different function. So this wants to create the codebook, which was done differently in Gustron's implementation. Yeah, you're correct. Okay. So now we do create tree. This is the part I'm having a little bit of trouble thinking about. So we say nodes is equal to a priority queue of all the nodes. As for creating the types, you can just create the respective type leaf branch. You're correct. So we can just say temp node here. So we'll say temp node. Ooh, that is messy. Okay, so we say temp node, and this is going to be creating all the nodes to iterate through. We have node 1, node 2. Okay, so these will be the leaf nodes then. Yep, it's not as messy as I thought. And then we just remove these guys. So we have wait key and some sort of standard bit string. Then in here, what we do is we say branch. And then it should be the same as it was before in principle. We have encode. Let's see, do we use big capital node anytime in here? Node. Constant node. Priority queue of all the different nodes. Huffman tree node. I think this should be okay. So let's go ahead and do this. Huffman.jl. Let's see what it breaks at. As for creating the types, initial nodes are all leaves. Other loops. Yep, that's correct. So let's see, what's the problem here? It says we have something at 34. Temp left bit string is equal to temp bit string 0. Type branch is immutable. Okay. So let's see. That means that we cannot modify it. Branch doesn't have a key. Oh, yeah, the way I wrote this, it does, but I should probably get rid of it. Yes, so it should be this guy. Okay, so now we have the problem with the immutable guy. On the upside, create tree seems to have worked okay. So now we have to work on creating the code book. So let's go up here to the creating of the code book and let's see what we have. It is immutable, which basically means that we cannot change it after its initial creation. So it should take one less argument. Okay. So I guess, let's see. I should just be able to put immutable struct, right? But that's going to make it really annoying. Because then, let me check something real quick. Making it mutable also makes it really inefficient. I think. We'll see. Wait, mutable struct equals type? Yeah, you're right. I just didn't realize I was beforehand. Type leaf is immutable. Okay, so we have the dictionary. Type leaf has no field left. So let's go to decode at 99. If is no, so this is something I didn't change from before. So what do we have here? We have decode for I in bit string if oh, we want to check if it's a leaf node. So basically we'll go in here and we'll say if is branch, and what we want is the current, and then go down here, we say else, and we add some spaces in here. Oop, that was one too many. JuliaHuffman.jl. Okay, it works. Great. Okay, so here we have one with the union of the two different types. So we have the mutable struct leaf, wait key, and bit string, and then we have the mutable struct branch. Now the question is, can we make this more efficient? The answer is, of course we can. It's probably in this create codebook function that we can mess around with things. So the way that I was creating the codebook was I was kind of keeping a bit string that is changed. Like every node has its kind of like bit string held within it. So this means that, you know, we have like all these branch nodes, and the top one will be nothing. There's no string there. Then the one on the left will have 0. The one on the right will have 1. Then you go down further, and the one on the right will have 0, or the left will have 0. The one on the right will have 1, so on and so forth. So you just kind of go down, and then you have a collective bit string that's held as you move further and further down. That's naturally inefficient, and there's probably a faster way to do that. In fact, I know there is, because I think Gustorn already did in his implementation over here. Gen codebook here, return result. What do we have here? So he recursively goes down. Oh, do you search through it multiple times? Codebook returns tree. You can just pass the bit string to the recursive function as a parameter. Yeah, okay, so there's definitely a better way to do this. Should we talk about that, or should we move on to the canonical Huffman stuff? So the canonical Huffman stuff is actually really cool, but I don't feel like we have enough time to really go into it in depth right now, because we spent the whole time working on implementation details. So maybe we talk about this again, or we talk about this a little bit longer, and then we do the canonical Huffman stuff all tomorrow. This will have the added advantage that I can go through. Okay, how do I put this? So let's look at the canonical Huffman real quick. So here's the thing. Huffman encoding is like one of my favorite just methods. I don't know why, I really like it a lot. When it comes to canonical Huffman encoding, basically the idea is to take Huffman encoding and make it more efficient. As far as that's concerned, the idea is that we do a bunch of different things, like for example with the codebook, and we can very easily change the codebook that we have from Huffman encoding into a canonical codebook. And this basically allows us to keep the codebook with fewer elements, if that makes sense. So like we basically don't have to hold as much data for our binary tree. Now let me think. The thing is, on top of that, we have a way to create a Huffman tree exclusively with canonical encoding, so that we go ahead and create the canonical encoding straight ahead without creating a Huffman codebook first. Does that make sense? So one way to generate a canonical Huffman codebook is to create a standard Huffman codebook and transform it. Another way to do it is we start at the start by creating the canonical Huffman codebook. I understand how to take a standard Huffman codebook and transfer that. It's very simple pseudocode. To do anything more complicated, I don't fully understand yet. So if I take a little bit of more time today and look into it, I think we can figure it out. So I think that's what we should do. Tomorrow should be exclusively for canonical Huffman encoding. You can pretty easily implement it so that it's only allocated one extra string. Yeah, I probably can. Let's see. So we have the create codebook. We have temp left bit string. We can concatenate the 0. Maybe we can. Maybe we can do this very simply. So what if we do codebook temp key. Instead of having a temp bit string at all, let's just do bit string is going to be equal to the following. Then we just say if is branch temp. Yeah, okay, let's do it this way. We're just going to say bit string here, and same thing here. And then we just say this here. Well, that's not right. Okay. So in this case, it said B was 0, 1, 0, 1, A was 0, 1, D was 0, 1. Yeah, that's incorrect. That's definitely incorrect. So we have this bit string, which is nothing. Pop the last value between the two pushes. Okay, so what you're saying is also after the last push. Okay, let me think. What would that do? Bitstring is equal to bitstring. So we add the 0 into the bitstring. It decodes it as ba. It's like a sheep. That's clearly incorrect. Let me get some water real quick. Okay, so we say temp.pop s is branch temp. So we're asking, is the thing that we're on technically a branch? Right, so we're somewhere. We're somewhere in the tree. We're asking, are we on a branch? If we're on a branch, then we say that we add a 0 if we're going left, and we add a right, or a 1 if we're going right. Okay, so now we say you go 0, 1. So then we go right with 0. Okay. Oh, maybe I do this. One second. And then we go down here, we just say bitstring no, that's all A's. And simpler. Why wouldn't you go with a recursive traversal for a recursive structure? I mean, this is the depth first search, right? I just used a stack instead of the recursive method, right? So you can do a depth first search with a stack, and that's the way I implemented it here. But you can also do it with like a recursive function. It's just some languages have like a recursion depth. Julia, I mean, Julia does. I just don't know how far it is. I don't know. Typically, when people do depth first search, my understanding was most people use the struct variety of it instead of the stack variety of it instead of the just recursive one. Oh, you have an uptime now. It's incorrect, but you have an uptime. That's pretty good. 3 hours and 53 minutes. Wait. Your first version of what was correct? Lol. Okay, let's see. What do we have here? So this one didn't work either. We also now have an AAA command. I added that one yesterday. I think it should work. Yeah, there we go. Arcane Algorithm Archive. Woo woo. Okay, so... Dagger Puppy, what up? That uptime? Sig Fig seems a little ambitious. You were totally right. It's just like 3 hours, 53 minutes, 46 seconds, and 46.96040 whatever seconds, nanoseconds or whatever this is. You know, like you go down to the nanosecond range. Okay, so let me think. Can we do it with the stack, or do we need to implement the other depth research? Temp is equal to pop s. Temp bit string is equal to bit string. I don't think that's going to work exactly. So basically the idea is, let me just go over here and let's draw this out. Page, new page before. Every time we go left, we want to add a 0. Every time we go right, we add a 1. Or something like this. So if we go left and then right, the temp bit string will be so if we go left then right, it'll be 1 0 1 0 1 0, something like this. Oh no, both my sentences are wrong. I imagine you're just like, oh no, both my sentences are wrong, and you're just like fading away. I'm sorry, I don't know why. For some reason, I don't know if you guys do this, but like I've watched so many cartoons that every once in a while I just think of things like in this weird cartoony sense of humor that just doesn't make any sense unless you're literally in my head and I like draw it out for you, you know? Like I've got a really dumb sense of humor, sorry about that. Okay, so if we go left we add a 1, if we go right we add a 0. So we have some sort of bit string. So bit string. So first we go left, we add a 1. Then we go left again, we add a 1, right? Now the next one will be a 0, so we need to get rid of that 1 and add in a 0. The temp bit string thing seems like it should work though. But it's because of how we're popping this thing, because of how we're going through this data structure. So basically, we add the 1, we add the 1 again, then we pop the 1 and add in the 0. Yeah, that's correct. So we pop the 1 and add in the 0. Okay, maybe that gives us something. So maybe what we need to do is every time... I've watched a few sitcom episodes, and it can be that I start to behave like I'm in one. Sadly, it's only funny for one. Well, to be fair, with a lot of sitcoms, you have like the laugh track in the background. So like, as long as you hear this laugh track constantly, it's probably okay because it sounds like you have a live studio audience. So... I can just imagine like you're walking into school one day and then all of a sudden you say something that's like absolutely hilarious but no one laughs. But like you have this laugh trap going on in your head, so it's perfectly fine, right? Because you think it's funny, so it's okay. Okay, so bit string. We want to continually append to this bit string. Maybe what we should do... I just want to use a stack. I don't know why. I just want to use a stack for this. I know we could use a recursive function, but I'm going to try. So we append the 1. We append the 1 again. Then afterwards we pop the 1 and we append a 0. After that we pop... that's not going to work, is it? That is not going to work at all. Yeah, I see no way to do this in that way. Unless we send some sort of bit string. So 0 1. It ends up just going like 0 1 0 1 0 1 0 1 or something like this. It ends up becoming like the worst type of prefix code. Let me go back to the version I had just a second ago. And then I will oh, dagnabbit. Get diff. That's not what I want. Get diff Huffman.jl. And I want to scroll down just a little bit. Where is it? I'm looking for this guy. So what I want to do is temp.pop. If type of left, temp.bitstring equals bitstring, 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 lots of bit strings. Temp.bitstring. What do we have here? Temp.right.bitstring is equal to string of temp.bitstring plus 1. Oh. It should be left. Just to make sure this works, temp. And then we do the same thing down here. So it should be temp dot right, and then we do temp dot bitstring. And in principle, this should work just okay. Q Julia Huffman.jl. Dagnabbit, bitstring is not defined. Where is bit string? Let's do 39. Oh, should be temp. JuliaHuffman.jl. Okay, this one works. Oh, except it's missing the... No, that one doesn't work. That one's wrong. Shoot. Dag nabbit, I promise this was working at some point. Okay. Dag nabbit. Screwed this one up. Let's run the git diff again. And let's see what I'm doing wrong here. No, those are the temp nodes, but we had it working outside of that. So let's see. Codebook is equal to dict char string. We say type of temp left if is branch left. Then we do temp left bit string times equals 0. Then down here, we say it is times 1. Right? So that should be left, that should be right. And then we push it, temp left, temp right. Temp left bit string. It's going to be equal to string of temp bit string 0. String of temp bit string 1. Temp of string bit string 1. If it's a branch, that means it should have a left and a right node, so it should be okay. Then we put else codebook of temp key is equal to temp.bitstring. Dang it. Okay, I'm doing something stupid here, I'm not exactly sure why. It's okay, Gaston, don't worry about it. Type of temp left equals empty. I do this, let's see what we have. Open link. Codebook recurse. Yeah, okay. Codebook recurse push code 0. Function gen codebook. So we have codebook recurse here. Okay, so it's leaf, codebook. Okay, so we have two different ones, one for a leaf, one for a branch. Good. Now we have code string, dict with the dictionary in it. So then we push code 0, codebook recurse. Our code is a string. We pop the code. I must have missed the refresh. Okay. So now we say push code 0, pop code. Yeah, okay, I can probably add this in. That's actually correct, I think, Symbot. Good job, JSPP. That's pretty cool. I should just like quit using Nightbot and just use Symbot from now on. Okay, so what do we have? Codebook recurse. In principle, these should work. So if we have this guy in there, let's see what happens. So let me just try these, because for some reason, whatever I'm doing is just not working. Codebook recurse. These should work almost directly, right? Result is equal to these guys. Let me just comment these guys out over here. And let's go ahead and paste this here. Because for some reason, whatever I'm doing is not working. Tree is not defined. 39. Codebook recurse tree. I said node. Leaf has no field char. Where's this guy? This guy's gonna be 22. Leaf dot key is what I called it. Convert string to type char. This is gonna be at 22. Join code. Join. Join. Dictionary of leaf key is equal to join code. And it's saying, can it convert object type string to an object of type char? But leaf key is a... Oh, key is a string. Oh, I didn't realize that. Why do I have it as a string? Fine, fair enough. Okay, what's next? No method, codebook recurse. Branch, array, char, dict. Okay. String, string. Okay, well that's something. No method matching encode dict of string, string. One second, let's change these back to char, and let's do the same thing for all these guys over here, and just make that key a character. Now there's going to be another error that pops up, but I think we can fix it in just a bit. Load error, kind of convert object type string to char. This is 5. What? Wait. What? Leaf in 64. You cannot convert object type string to type. What? You're not even giving me a good line number, man. There's nothing happening at 5. Okay. Create tree. Oh, I see. I was doing this wrong. 129. So I also want to go to 84. Temp node is equal to leaf key. This needs to be an empty character, and this needs to be the 5 is probably because it thinks it's a constructor. Yeah, probably. 84. Oh, while loading an expression. Oh, that's why I did a string. Ah, it's such a pain in the butt. I did a string specifically because it doesn't let me, okay. That's fine, I guess. It doesn't let me put in an empty character, so I have to put in some character here. Oh my gosh, why is this such a pain in the butt? Okay, unfortunately guys, I gotta go for now. So we have a version of it working that's up on GitHub right now. We got a bunch of things I need to fix though. So let me go ahead and write down the list of things that we need to fix here, figure out the best way to implement things, and kind of go from there. So as we have it set now, we have to figure out how to do the, I need to get a working version with the leaf and branch struct. So leaf, branch, union, because that's currently not working. Then we need to do this, the codebook, to fix codebook. So it doesn't have, it doesn't carry the string. Okay, so that's what I need to figure out. Two things. One, I need to get the immutable struct stuff working here. I want them to be immutable structs, so this means I don't want to carry this bit string around with it. So I want to get rid of these guys. So that's what I need to figure out how to do. I wonder if my bot crashes if I write uptime after the stream ends. I'm not sure. So anyway, guys, that is it for the day. Sorry we didn't get as far as I wanted to. I guess tomorrow I'll go ahead and try to figure out if I can fix up this stuff today. And then after I figure that out, we'll talk about it tomorrow. When that's done, I will then start working on canonical Huffman encoding tomorrow. So that's the hope, that we can get all that done. And that's about it for the day. So thanks guys so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. If you're not already on Discord, feel free to go there. Obviously check out everything else that I have, that kind of stuff. Thank you guys so much for coming in, and I will see you guys next time. Bye guys.